Hi, welcome after the break. And now we're going to hear about building large applications based on Django admin. Well, please welcome Mateusz.
Thanks. I hope you enjoyed the lunch. And my name is Mateusz Kurek, and today I will talk about building large, fully featured application on top of Django admin. The slides for this presentation are available at Allegro.tech/Django admin PDF. I will show you this link at the end of the presentation too. So I work as a senior software engineer at Allegro, and for those of you who doesn't know what Allegro is, especially from the ones not from Poland, Allegro is the biggest e-commerce platform in Poland. We have over 20 million users. We have about 20 million monthly transactions and over 3.5 billion page views monthly. What about some technical numbers about Allegro? So we have over 700 microservices. Right now we are processing over 25,000 requests per second on our data bus. We store 4.5 petabytes of data in our data store. And we have 2 data centers where we have over 5,500 data center assets, physical servers. And in general, we have more than 10,000 hosts, either physical, virtual, cloud, and so on. And that's where RAL comes in. What is RAL? Because this whole presentation will be the story about RAL. RAL is our asset management system for data center and back office. We store in it our physical servers, virtual servers, back office assets like laptops, monitors, and so on. We store the licenses, supports, domains we buy, and so on and so on. RAL is fully open source. It's available at github.com/Allegro/RAL. And it's developed in Allegro since 2011. This project was initiated by Łukasz Langa, now one of Python core developers. And RAL was based on Django from the very beginning. First version of RAL was based on Django admin 2, then we have some customized user interface working side by side with Django admin, and now we have third version of the RAL. So, what was the disadvantages of the second version of RAL? It has poor API and not so old models. It was the whole information was separated into 2, even 3 systems, and there was a little tiny connection between objects in those systems, and it was really hard to keep this information up to date in every place. Adding new features that take us a really long time. We have 2 inconsistent user interfaces. One, our custom-made interface, and the second one was the admin interface, Django admin interface. But the truth was that everybody in the company has access to the admin interface, and some of our administrators told us that they are working on admin because data in admin is more reliable than in the user interface. But of course it was the same data stored in the same database table, but only presented in different ways. And last but not least, it was written in Python 2, and migration to Python 3 would be really painful, especially because some external dependencies. I don't know, it's not really visible, but this is how RAL, the second version of RAL looks like with this user interface. So in May 2015, we made the decision that we're going to rewrite this RAL from scratch, and we will use Django admin as our foundation, and it will become our only user interface. We've used MySQL. All versions of RAL are based on, we use MySQL as a database. And this is how RAL looks like now. I guess that if I will show you this, nobody would expect that this is Django admin application because it looks totally different than regular Django admin. So we customized it pretty much. And the reasons behind choosing Django admin as our foundation was that we want to have one and only one user interface. We don't want to have this confusion anymore about storing information, presenting information in two different ways. We want to have easiness of adding new models, especially in a declarative way, presenting them in a declarative way, because Ralph now has more than 100 models, and I guess about 90% of them is just simple listing and crude form, and we don't need any fancy features here. So admin is a perfect fit here. And the other reason was inlines. I love Django admin inlines and the easiness how we can manage some relations. And Django admin has a lot of external packages, and it sets some boundaries where we could write our code and what structures do we have to use. So before I go further, how many of you are familiar with Django admin? Okay, pretty much half of you. So for those of you who are not familiar, I will show you some built-in features Django admin gives us out of the box. So first of all, the list of models. Every model in our app which is registered in Django admin is visible on the listing. We have the view separated for any application that we made. And when we go and click on some particular model, we'll see the listing of the objects created for this model. And to create such a Django listing, we just have to make 3 lines. First one is registering our model, then definition of the class, and list display parameters specify what columns will be visible here in the admin. Here we specify that we want to columns such as username, email, first name, last name, this stuff, and such columns are visible here. Django admin offers us also some simple filters and search marked with the red line. So when we add parameters such as this filter and search fields, of course in a declarative way, because a lot of Django admin code is written in declarative way, we specify what fields we want to filter by and what fields we want to search by. And when we click on some particular object, it's really not visible here. I will turn on the light if I will not know. Better to not that. Okay, so when we click on some particular model, some particular object, we'll see the form where we could create or update or delete some particular object. And again, 3-4 lines, and we have ready to go form in Django admin. But Django admin supports also features like custom actions. So we could write our own action, and on the listing of the object we could select objects we are interested in, then select the action, run it, and our custom business logic will be executed. In this example, I registered the action by adding the actions list, and there we could have some custom business logic. In this example, we update some models in the database. We also have inlines. Inlines are really useful feature for managing many-to-many and one-to-many relations from the point of view of single object. And it allows us to add as many related objects as we want. Again, few lines, definition of inline class, putting it on inlines list, and it's presented by Django admin on our form. We could specify pretty easy our custom form widgets, and in general our custom form. Once again, few lines of code where we specify the widget field in nested meta class. We use here something like filtered select multiple. It's built in Django, and it allows us to manage many-to-many relations by dragging or clicking to move some part to selected object or not. The other feature built in Django admin is callable field on listing, where we could specify when we put on the list display field something which is not filled on the model, Django admin will try to find some callable with this name. It will look for callable on model and or in admin itself. And we have callable function called getServices, which takes our one object and returns the value which should be put into this particular cell of this object. We could of course specify the title of this column, how it should be ordered, and so on. And Django admin has a lot of many other features like ordering. We could specify how many items per page will be visible. We could define what select related or preference related queries will be executed. And going to the third version of RAF. First of all, how did we start with this application? We've chosen our front-end framework. We used Foundation here because at this time we were really bored with Bootstrap. Every other app, our internal app, written in Bootstrap, and we want to try something new, try something else. So we choose Foundation, and we don't want to have the listing of the models defined in admin out of the box. We want to have some horizontal menu, two-level menu, and we use Django side tree to achieve this. We have to override a lot of Django admin templates. Because I don't know if you are familiar with it, but if in your own application, if you define admin directory, in template directory, and create a template named the same as template in Django admin, this file will override the template in Django admin. So we have a lot of templates customized to make this many model form and so on customized for our needs. And we've created our own extensions of model admin. This is the most used one class in Django admin, and we call it RAF admin. It has all the features we will use later included, and we want every developer working on RAF to use RAF admin to add some model and display it in RAF. Of course, we didn't write everything on ourselves. We use a lot of external libraries, such as Django side for making breadcrumbs. I showed you this before. We use Django version for storing history of objects. But in my opinion, it was a bad decision. I had nothing against reversion, but in our we'll find out more useful libraries that will show us the difference between models in time, and we are not releasing the feature of going back to some particular revision. We use, of course, Django Rest Framework for the REST API, and the library called Django Import Export for importing and exporting the list of our objects to CSV or Excel format and so on. We should use some autocomplete library, but we decided to roll this feature on our own, even twice, and in my opinion, it was a bad decision. But during working on Rust, we make a lot of open source contributions, even to Django and one of many of those libraries. And now I'm going to show the features we've introduced in Rust. A lot of them will be related to Django admin and somehow integrated with it. And this will be more some inspiration or overview of this feature, because I could give a separate talk about every of this feature. And what's most important, every of this feature I will show you is implemented in generic way, and it should be easy to migrate it or use it in another project. And I hope someday we will take it from Rust and release it as separated open source library. So let's start with extra views. Django admin doesn't allow us to create some extra views, but since we have our own menu and we could manage our own URLs, we have a need to create our own views, and it's plain Django stuff, some templates, adding it to URLs. We decided to use Django template view using Django class-based views, of course, and we created with such as extra views the feature called, for example, this is visualization, when we visualize how every rack is, where each server in the rack is placed and where each rack is in our data center. We use Angular for this feature too. But the most interesting extra views are extra views for some particular model, because we have so many information about the single object that we wouldn't be able to put it everything on a single page. So we have two ways to add such a customized view. We could use either some view with template and define template everything on our own, or use something similar to Django form views and use declarative way to specify how the form will look like for this extra view. There is a little bit magic under the hood with saving the context of the current object, which we are working on now. But when developers use classes such as relative view or relative view admin, this first one is used for template views and the second one for the form views. It would automatically handle for him the adding the tab, placing the right icon, the name of the tab, adding it to URLs, and managing this URLs. So how does this extra view for particular model looks like? So this is an example of form-based view. Every extra tab is visible here on the left. And here we have just a simple form with single inline. It's regular admin inline. And the second example I have is template-based view, where we specify everything on our own with Django template. And how does the code looks like for such a feature? So the first example here is detailed view admin, where we use Django admin form. We could specify, of course, icon name, label, and the URL name, and it's handled automatically by detailed view admin. Then we specify some form or some inlines, put it on inlines list, just as in regular Django admin, and it's done. In the second example, we use Run detail view, and we specify also the template name, is the path to the template. Of course, we add some additional data to the context to be able to process it in the template. And at the end, to our regular admin, inherited from Run admin, we have a list of change views. This list is responsible for generating the tabs. We put here our 2 extra views, and we are done. If you are more interested in how we implemented the tab, there is a link in the right bottom corner of the slide. Everything is stored in Ralph repository, as you could, because it's open source, you could easily see how we implemented it. So the next topic I'm going to talk about is polymorphic models. So let me ask you a question first. How many of you knows the styles of model inheritance in Django? Okay. So there are three ways to inherit a model in Django. First of them is abstract-based classes, and in abstract-based classes we use the parent class to store some common information that we'll use later in child models. But the most important information is that database table is not created for this abstract model. And how does it look like? We create a model, regular Django model, with inner meta class and set the property abstract to true. Then we will inherit from our abstract model, add some additional fields, and when we look at the database, we only have 2 database tables for the non-abstract models. And each of them is storing information both from the parent model and its own model. So the second way to inherit models in Django is to use proxy models. And in proxy models, we change the behavior of the model in Python code. For example, we could change the default manager, add some filtering to the query set, add some ordering, and so on. And this model operates on the same database table as its parent model. But the query set still returns the model that was requested. So if we request for the proxy model, it will give us a proxy model. If we request the parent model, it will give us the parent model. And how does it look in source code? We have some base parent model, it's called the person. Then we have 2 proxy models. First of them is ordered person, which inherits from person, add proxy true attribute, and in this case, some ordering. And this is done, let's say, in Python. Yes? It's using the same database table underneath, but it's influencing the way the objects are retrieved from the database. The second example here is underage person, which filters out the person who has more than 18 years, should probably filter by less than 18 years. And we define custom object manager here, and of course using proxy attribute in nested meta class. And the last example of the last way of inheritance of models in Django is multi-table inheritance, and it's the most powerful way to inherit models, but at the same time the most complicated way. So, first of all, each model in the chain of inheritance is a separated model by itself. We could, every model is saved independently to the database, and has its own database table. And each model can be queried and created individually. So we could create either parent object or child object. And there is a link between the parent object and child object using Django one-to-one field. And let's see how does it look in the database. So again, we have our person model, student model with some additional fields we inherit from the person, but this time we don't add any meta class with some attribute here. And the same way we create employee model inheriting from person. And in the database we have now 3 tables. That's the difference comparing to the abstract list classes. In the first one, the person table, we have all the fields we will expect, so ID, name, and age. But in the student and employee field, we have person PTR ID. It's the one-to-one field pointing to the identifier in the parent table. And some examples how to use it. We could create a student object and employee object. All of them have the common fields and the custom fields. And when we call, we could select all objects from the person point of view, but we'll get person instances. So only with the common fields like name and age, without access to the custom fields like home group and compound. We could of course run some filtering here, but what's most important that the model was requested will be returned. And in polymorphic models, the goal is to call some manager and call it on the person, so our parent model, but don't receive the person object, but our final child object. So we call it on the person, but receive student and the employee. And we did it in Rust. You might ask, why we did it? Because we need some common namespace for identifiers. There is a thing in Django called content types, which handles some generic relations between when we could create some foreign key to any model we want, but it's stored in 2 database fields. One of them is the name of the model, and the second one is the identifier of this model. We didn't want to use it, we want just a single field to store information about the identifier of this model and be able to identify particular object by a single value. This parent model will enforce some common fields like name, service, and so on. And we wanted to have some easiness of querying for related objects. For example, we want to include in the result only host of some particular types, which are the model by itself, but to somehow union this result into one query set. So how our polymorphic model looks like? We have base object. We inherit from polymorphic and use some polymorphic based meta class here to achieve it. We import this from Rust in polymorphic, and every code related to the polymorphic is in this package. So it should be really easy to use it somewhere else. And from this base object we have some inherited models like data center, assets, cloud host, which add some custom fields. And Rust polymorphics has some additional features. First of all, it has polymorphic select related and polymorphic prefetch related. Select related and prefetch related is the way to say Django to do some join in the database, or this is select related, and prefetch related is for prefetching all the related objects in a single query. This is especially useful for many-to-many relations, and to do this in the optimized number of database queries. So, in this polymorphic select related, we could specify what select related, on what fields select related should be executed when we'll touch some child model. So, for example, when our polymorphic object will handle my descendant model, it will select related this field, but when it will get my descendant model 2, it will select related some another field. The next feature is easy access to the final class, the final child instance through the last descendant property, and the polymorphic object is the default manager. I don't know if you know that, but the default manager is the first one which is placed in the model, and this default manager is used, for example, automatically by Django. And underneath we used content type framework, but just to point out from the base object what type is our child object. So we store only the information about the type of the child object. We have custom query set. We have only our iterator method, which, as the name suggests, iterate over each result of the query set. And how we've done it here. First of all, we call super iterator to get the list of the base object. This is our parent class. And we extract from here all the content types and primary keys that occur in this query set. We group this object by these content types, and for each content type, we make a separate query fetching only the primary keys we are interested in. At the end, we put it back together in single list, single query set, and restore original order of items. And of course, we did it in optimized number of queries, because we do one query for the base object and then only one query for the single content type. And again, if you want to find out more about polymorphic, there is a link here in the sources. Ralph did polymorphic. Every code we wrote about it is here. So the next feature I will show is transitions. And transition is the set of actions to be executed on some single or many objects. And originally the thought behind it was that it should move the object from one state to another, change some status or state of the object. But eventually we left this condition. We define action in code, but we could select which action will be executed in single transition in user interface. The transition might be synchronous or asynchronous. The synchronous transition is executed during processing the HTTP request, and the asynchronous transition is processed in the background using RQ worker. It's something similar to Celery. Transition might be in frozen state, which means that it's no longer processing, it's back up to the database and waiting for some external event to occur, for example, HTTP request, which will unfroze it and keep the processing going further. And our transition might produce one or more attachments, which will be visible later in the history. So that's how we could define a single transition. On the right, we have a list of available actions. Each of these actions is defined in the source code. It's separated function, and we select which actions we are interested in terms of our single transition. We give it a name, specify some statuses, but doesn't really matter. Specify if it should be synchronous or asynchronous, and by default, each action with this I don't know the English word for this timer, let's say, is executed by asynchronous by default. So to execute the single transition on the object form, we hit the transitions button, select the transition from available transition from the list, and execute it. We have also ability to select multiple objects on the object list, then call actions, and here we have every transition created for this particular model. We automatically add to the actions list in admin. So some transitions require us to fill some data. For example, here we have a deploy transition to set up a new host, and we specify what hostname we should have, IP address, MAC address, and for example operating system which this host should have. And this transition, of course, is asynchronous. It's running in the background, and later we could see the current progress of this transition. What action has been done, what data was transformed by, and who executed this transition. We have, of course, the view for the history of the transitions, where we could easily see who calls what transition, with what data, what attachments produced, and so on. So, how does it work? How did we achieve it? There is a lot of plain Django stuff like forms, model, views, nothing really magical. We create all of the objects. For example, actions which we could select in the transition view during post-migration step. Post-migration is some step which is the function, let's say, that is executed in Django after running the migration of the application. As I said before, we used RQ to run asynchronous transitions, and we have transition action decorator for configuring or decorating the function which will be available as a transition action. And in source code, we have two examples. I have two examples of transition here. One is on data center asset. It's just assigning some rack to the instance. But what's most important is the definition of the transition action and available params here. We could specify the name of it. We could specify some for fields, one or many, which will be which the user has to fill to run this transition. And on the other side, we have also some other things like return attachment, precondition. We could specify the order in which some actions are executed, because one action might depend on the other action and has to be executed after some other action. And inside the transition, there could be pretty much any business logic we want. And once again, if you are interested more in how we implemented transition, there is a link for it on the right hand corner. So, the next feature, granular permissions. So in Django we have Django admin has 3 permissions by default. First of them is adding, second is changing, and the third one is deleting object. And we set it for each model. We could specify this permission either on the particular user or the group of users. And in Django, there was a lack of view permission. It was added in Django 2.1, like a month or 2 months ago. There are a lot of open source packages for handling more sophisticated permissions, like Django Guardian, Django Rules, but it doesn't really fit us. We need something more. So in RALF we have 4 levels of permissions. First, one of them is permissions for model. It's the plain Django admin permission that's given out of the box. The second one is permission for some particular object. The third one is permission per field. And the fourth one is permission for viewing some extra tab or running some transition. And we used there was a lot of work with meta classes here. In general, if you want to modify Django, there will be sooner or later a lot of work with meta classes because, for example, the whole Django ORM is based on meta classes. And to manage this, going back to the permissions, to manage them, we added some modified some of the widgets for the permissions in group order user, where we have each lib model we have available in app. And when we click on the model, we have checkboxes with permissions for this user or the group. In this example, we have a simple model with the plain Django permission with our additional can view permission. But in the most of the more sophisticated models, we have many more permissions to select. As I said, we could select the permission for running the transition, viewing some extra tabs, changing or viewing some particular field. And let's go through the levels of permissions. First of them is permission for model. We scan all models and its fields and create permissions for them. As I said, permission for adding, changing, and deleting is handled by Django. And what we had to make was rendering menu for each user based on his permission. So one user might see the menu in this form, but the other one with another permission will see the other models in the menu. Permissions for object. We have to override some Django admin methods like has change permission, has delete permission, and get query set to narrow down only to the object the user has permission to. And if the model will use the permission for object, it has to inherit from permission for object mixin and add some nested class permissions with has access property. I will show you an example in a minute. And what's most important, that Rel admin provides both permission for object and per field. It handles it underneath. The developer doesn't need to worry anything about it. So, the example. We have back office asset model inherited from permission for object mixing. We have some regular field here and nested class permissions which has access property. It points to some function which should return some filter added to the query set. It gets the user as a parameter and should return some filter that would be injected into the query set, and it should narrow down the query set only to the object that the user has access to. Permission per field. This was the most tricky one from the permissions, because a lot of Django method has to be overwritten. For example, get field sets, get read-only fields, get form, and so on. And in a single form, we could present some particular users different perspectives. First of all, the model has to inherit from per by field mixing, and later is handled again by the runtime. So we could present the form in a different perspective for different users. This is how the super user shows the form shown to the super user. Every form field is changeable, but when some other user with lower permission enter this page, he sees much less fields, and more of them are read-only. Only few fields can be changed by this user. Again, some other example when the whole field, the whole part is read-only, and other fields are made changeable. It's especially useful because a lot of teams is working on the same in Ralph on the same objects. For example, financial team, and it's interested in putting some financial info like price, invoice information, and so on to the Ralph. But the administrator team it doesn't really care about what was the price of the server and what was the number of the invoice. It has to manage things like host name of this server, where it's stored in rack, and so on. So on a single view, we could present this form in a little bit different way for different users. Okay, so let's go to custom fields now. Custom fields allows us to specify some fields and values for objects that are now hard-coded, that are not presented in source code. We have also ability to inherit custom objects values from some parent objects. And the custom fields might be one of many types, like string, choice, bool, int, and so on. And how does it look for the user? So on the left we have for defining the custom field. We give it a name, monitoring prototype, selecting that it will be the list of choices, and the choices are manual, auto, backend, and so on. And on the right we see how we use this custom field on the single object. We first type the name of the custom field. From the autocomplete we solve it, and the value should change accordingly to the type of the field we selected. As I said, we could inherit the value of the custom field. So this is the parent object. This is definition of the service, and we specify some custom field cluster here with the value command. And when we have some object attached to the service, we could also specify some custom fields here, but the cluster field in this example will be inherited for this object. And how we do this? We used content types here to attach the custom field value for any object. Of course, we have to write some custom query set, generic relation, and generic descriptor. And especially hard here was prefetching all custom fields in one query from the database. It's maybe not so hard as it sounds, but it was hard putting in generic relations in Django. They are really sophisticated in my opinion, and sometimes there is so many logic in a single function and you just want to change a single line, but there is some nested class generated dynamically in a single function, and you have to copy it to your code and change the single line from your code. We did some custom forms and inlines and provided some additional resource in the API to easily manage custom fields through the API. And in source code, our model has to inherit with custom field mixing at some meta class, and custom fields are automatically attached to this model. In admin, we have to inherit from custom field value mixing, specify some property, and the custom fields box is of course presented automatically. And in API, the same stuff, inherited from some mixing, and custom fields are automatically handled by our framework, we may call it. Okay, let's go to the next feature, charts and dashboards. So one day, one of the managers came to our office and said it would be great if we could visualize, for example, how many assets we have on stock, or visualize something else, something other information from Ralph. We didn't want to make just one shot dedicated from him. We want to make some generic solution, and that's how Ralph charts were born. And Ralph charts allow to visualize data from Ralph pretty easily. It uses ORM like the declarative query. Underneath it uses Chartist, JavaScript library, to display this chart, and single chart could be connected together and put it on some dashboard. And this is how some example dashboard looks like. We have the ability to show some pie charts, vertical charts, and so on, and how we define it. We have simple form when we could select the model, some aggregation type of the chart, and here is the whole magic that is going on here. We could specify some, as I said, ORM-like query to filter or specify the x-axis and y-axis on the chart. We could also push this data to some graphic or stat-d, because Ralph presents only the current state. We could store the historic state in the graphite or stat-d. We have many aggregation types like count, max, sum, etc. And a lot of models from Ralph is used in this chart. Okay, next feature is filtering. Django admins filter are really simple, but in my opinion they are too simple. We want to create something much more powerful. So we created our own filters for a lot of types like integer field, choice field, foreign key, and so on. Each filter has its own template. It will tell us how to render this field, for example, using some HTML input tag, select tag, and so on. But the most important thing that we want to keep it as simple as possible. So to define this field still in declarative way, putting name of the field on the list filter list, and the rest should be handled automatically. So this is how filters in Ralph looks like. As a reminder, the filters in plain Django, it was just a text. If it was choice or foreign key, we could just click on the text and, for example, we have foreign key with 1,000 or 2,000 related objects. It will present us the whole list of the objects, which is really bad. And here we could, for example, we have, for example, autocomplete fields. All of the fields with the magnifier are the autocomplete field, especially useful for related objects. And in a single field, we could specify multiple values using semicolon or vertical bar as a separator. This is the presentation how the autocomplete fields look like. We could select many values here as well. And to register our own filter classes, we use the feature of field facilitator. It's a class in admin, and it allows us to register some custom field for if some condition is made. And for example, we made a condition that if a field is integer field, use our own filter. If the field is char field or text field, use our another filter, and so on. But it isn't always enough. Sometimes you want to use some really dedicated filter for some particular field. And Django admin allows us to specify tuple instead of name of the field, where we put name of the field, but also the class that should be used as a filter. In this example, we inherit from the choices this filter, but override the query set to get only to add some custom logic to filtering the query set. And this is how it looks like on the phone, on the filters bar. Okay, API. As I said, the second version of Django has really poor API. We want to. The goal was that every almost object and every almost action that is achievable in user interface should be also done in API. We use Django Rest Framework, and of course this API respects all of our permissions that I've talked about before. And again, we want to keep it as declarative and as simple as possible. So Django Rest Framework consists of three basic ideas: serializers, viewsets, and rows. Serializers tell us how to put a model into JSON, let's say, what fields should be placed in this JSON. The viewset handles query set, filtering, ordering, and so on, and specify the serializer class. and the rows just handle this view set should be visible at this URL. So in route, we extend the serializers, first of all to handle the permission for field and for the related object. Now request and user object is accessible in the related serializer. It's not built in Django Rest Framework. We have added some tweaks in nested and choices field, but what's most important, we've added here something like CQRS, and the idea behind it is that we want to have very powerful serializer for fetching the object, but very flat and simple for saving and updating the object. And that's how our API-serializer was born. I will show you an example of it in a minute. Our viewsets handle select related and pref related in a declarative way. That's the thing that Django Rest Framework hadn't handled out of the box. We've added a lot of filters backend. For example, the double underscore lookup to specify some field greater than something, or some field starts with something. And we could provide our save serializer class or create it dynamically if it's not provided. An example of Route API, we have two serializers here, one for fetching the object and the one for updating the object. We could add of course, some additional logic here, but we put them on two separated fields, serializer class and save serializer class. We define some select and pref related and filters that the model should be able to filter by. Another example when we could specify some more additional filters from Django filters package and some useful feature called extended filter fields, that if we filter by service, underneath we will filter, for example, by those two fields. And the last feature I'm going to show you is bulk editing, and it's allows us to edit multiple items at once. Of course, it respects our permission, especially permissions per field, and we create some custom Django admin action book, edit action. And how it looks like? We select some objects, call some action, and here is how it looks. It's plain listing view, but not with the read-only fields, but with changeable form fields, and narrow down to only the objects we want to change. Some fields, of course, are read-only because of the permissions. And the cool feature about it is that we could easily enter the value in one field and propagate it through the whole column. In source code, of course, everything is defined in a declarative way. We define the list, the fields we want to be able to edit. Some fields that should not be fillable through the whole column. And Django admin has this feature built in. It's called list editable, but we tweaked it a little bit. We override get query set to narrow down only to the objects we selected, and override get this display to display only fields that user has permissions. And once again, there is a link here if you are interested how it's done underneath. Okay, so we are running out of time, so some conclusions about writing an app using Django admin. So, in my opinion, Django admin is a very powerful tool, but sometimes things get a little complicated, especially for some generic relations and stuff like this. If you want to customize Django admin or even the plain Django, there will be a lot of work with meta classes and sometimes with content types to make something really generic. It's not so easy to customize or extend the Django admin, but we didn't regret it. If I will have to make this decision one more time, I will once again choose Django admin as our foundation. Okay, so thank you very much. If you have any questions, I hope I will have some answers. Once again, there is a link where you could see the slide of this. I encourage you to go to the Ralph repository in GitHub. Yeah, thank you.